Welcome to my first little presentation all about LoRa. I'm going to do these every now and then when I feel like it, based on things I've done, because that's how I roll. Um, it won't move the slides forward. Why will you? There we go. This is a good start, Rob. My policy on these matters is never to stop and go back again. So I'm not going to stop and go back again. I'm going to keep on going forwards. It's the only way. So I'm going to look at what LoRa is, how it works, LoRa gateways and applications, and a thing called the Things Network. At the end of this, you should know what LoRa is about and how to put information into the LoRa system. The next presentation, which I haven't done yet, but I will, promise, will cover how to get data out and do things with it and how to make back-end applications that make use of that. So let's just choke gently through this. LoRa, clues in the name, low-powered radio, L-O-R-A, or long range. It's nice because it solves a problem that we've had for a while. How do you put sensors out in the wild when there's no Wi-Fi coverage, you can't run wires to them, and you don't want to spend a fortune on SIMs to make mobile phone devices, even assuming you've got mobile coverage in the first place. So LoRa solves this. It's got some limitations, but we'll cover those. It's actually worth taking a look at. So let's just go and do exactly that. LoRa, yep, designed for battery-powered devices where you want to put a thing out in a field or the middle of nowhere and have a battery life that's measured in years. So you won't go out and recharge this thing. There might be no mains there. The things themselves have LoRa transmitters that are cheap and very easy to add to a device. So you can have an existing device that's capturing data and put a LoRa endpoint transmitter on it quite easily, quite cheaply. It uses a thing called spread spectrum technology, which sounds absolutely great. And I could really use some of that, or probably not. The idea is that the messages are sent below the noise as packets of data in a cunning and intriguing way that's far too complicated for me to understand, but you just buy the chip, turn it on, and it works. Don't think of this as a streaming medium. Sending video over LoRa, not going to happen. Making phone calls over LoRa, not going to happen. But sending short messages of useful data like SMS texts, absolutely. That's what it's good for. That's where you should use it. And so there's limits on the message size and the amount you can send them, but we don't really care about that because we've got a thing that lets us send messages a long way for free using battery-powered tech, which is really rather nice. Yep, get about 15 in a very flat environment outside in the fields. You might get up to 15 kilometers. In urban environments, the range is a bit less. That's because the wavelength of the signal doesn't go particularly well through bricks and whatnot. But it does work, it is usable, and with a suitably sized network of gateways, of which more in a minute, you can do very useful things. 3 different wavebands for around the world. Don't do what I did, which is buy a whole bunch of 433 megahertz devices that are supposed to work in Asia, but not in the UK. No license required. It's a part of the unlicensed frequency space. But if you want to make a product, you should try and get hold of properly certified devices, and you shouldn't send lots and lots of messages. That's kind of breaching the usage guidelines. So be sensible, and it all just works. The idea is you can trade bandwidth for range. So bandwidth is the amount of data you can send in a certain amount of time. Now, sending video, lots of bandwidth, lots of data very quickly. Sending LoRa messages, small messages, over a longish period of time. Now, LoRa kind of sorts itself out in this respect. In that if it detects that the station and the gateway are very close together, it'll wind the power back a little bit. The packet size, yeah, 60 to 230 bits or so, and you shouldn't really send for more than about 1% of the available time. These are kind of important things to consider in terms of how we're going to use it, but we'll look at some scenarios in a minute, and things should hopefully at that point start to make a lot more sense. You can just use LoRa to make 2 devices talk to each other. So say you have a greenhouse a mile away with your prized marrow. It could happen, and you want to actually see how warm your marrow is overnight. You could buy 2 LoRa devices, and you could just basically use them as a telephone. One end will push a message into the LoRa wireless area, and the other, oh, hello, Jess. Oh, we've got mulled wine and stuff down at C40i. I'm not there, rather sadly. I'm sitting in my little room with a pair of headphones on doing this, but I'll get my mulled wine later. Don't worry about that. So, back to the plot. LoRa lets you do point-to-point communication. So I buy two LoRa devices, I put one in my home, one in my greenhouse. The greenhouse one pushes messages out there, my one at home receives them. It's a bit like a broadcast medium in that anybody else, my marrow-growing competitor across the way, he could get my messages too and find out how warm I'm keeping my marrow. Stay with me on this, it's a good scenario. So I may want to encrypt or add addressing or whatnot, but as a point-to-point comms thing, it makes it possible to think about sending things out into the field where you have no Wi-Fi coverage and you want to run on batteries and all that kind of stuff. So peer-to-peer does work. You can buy two devices and just use them. They come with the sample programs and you can just push data into one, get it back out of it. It works. It's great. But I want to talk about LoRaWAN, which is a wide area network built using LoRa. With this, you have applications which are basically services you want to provide using devices to produce data, and then servers on the back end generating useful behaviors from that data. We're going to talk about cow trackers because why not? In this particular situation, things are a bit more strengthened and industry usable type. They have encrypted conversations between the endpoints and the gateways, and the gateway, we'll talk about in a minute or two, does a lot of the heavy lifting in terms of moving packets around. But the idea here is that you're getting a proper application you could deploy across a city, across a county, across a country to get information into your network about values that your sensors are pulling in from the real world or from whatever you want to look at. Okay, so let's talk cow tracking, because cow tracking is kind of fun. Say I'm a farmer with wellies and everything, a tractor or two, and a whole bunch of cows. Now, my cow clip art, not got a lot of cow clip art, so I'm using, my cows are all clones, which is fair enough. I put an endpoint on all my cows. The endpoint contains a LoRa transmitter, a microcontroller, and a GPS receiver, so I can tell where the cows are. And every now and then, my cows will send messages back to base camp saying, this is where I am. Now, a LoRa gateway is the device that receives these, so my cows are out there sending their coordinates 2 or 3 times a day, because I'm assuming that cows don't move that fast. And the LoRa gateway takes those messages and pushes them onto a thing called a LoRa server, which is on the internet. So the link is a network connection. So if I am a farmer and I have a whole bunch of fields, at one end of the field I might have a gateway with a wire back to my home network or whatever, which provides the network connection. So the idea is that the cow message gets sent, the gateway picks it up, the network sends it to the server, and the server then pushes it into whatever the back end that I want to use actually is. So I can receive this thing and I can, I don't know, I can have a map and moving cows and things, which would be nice, and alarms that go off when cows wander too far off top field, whatever it is that farmers like to do with their field names and things. So this is kind of how it works. It's a great LoRa app because you can make things battery powered, the data rate's fairly small, you have a large area to cover that might not have Wi-Fi. It's a nice way of thinking about things. So there you go. If you have multiple gateways, lots of fields, that's fine. They're all wired back to the same server. This cow here, when he sends where he is it he or she? Anyway, when the cow sends where they are, this gateway and this gateway both pick up the signal. That's fine. That means your back-end server gets a message that says these gateways saw that signal. And so you could do some broad guesstimating of where things are based on which gateways picked up the message and how strong the signals were. But we've got a GPS on our cow, so we're all good. It's a question of how you build it, how you use that information. As it says on the slide, all the incoming messages are tagged with the gateway that received them, which is kind of useful. So a gateway is basically a LoRa receiver and a network connection. It gets messages from the endpoint and passes them onto a LoRa server. You can, if you want, this is possible, but I don't really advise it, you can use a cheap LoRa endpoint chip as a gateway, but they don't expose all the abilities of the LoRa network. There's some things you can't do if you're using a cheap gateway. A proper gateway has an 8-channel radio receiver and costs around £120, and it runs on a Raspberry Pi, which is kind of good, and you can place these high and outdoors. That's a good place to put them, and there are various aerial designs on the internet you can find to make the signal even stronger and spread even further, which is nice. This is a single channel gateway that I bought from Dragino, and it does work, but like I said, it's a bit limited in terms of what you can do with it. Great fun for playing with and getting started, but if you want get serious about this, I get a proper gateway. Or if you're lucky, like we are in Hull, the council will be rolling out some citywide LoRa gateways that we can all use. So just use one of those, find somebody else's. Once you put a gateway up and make it work, you're providing service not just for yourself, but for everyone else around you. And that's a lovely thing. It's a nice way of sort of growing the network using helpful, nice people, which is rather good. The Things network is, I think, at this point we should really mention, because I've mentioned this back-end stuff, which you could build your own of. You could actually get your software and your servers and set it all up and run your own LoRa network, soup to nuts, all the way from cow to cow map. That's fine. But if you don't want to do that, the Things Network is an organization that basically provides open source hardware, and it underpins a worldwide network of open LoRa gateways. So I can take my device, my cow, can take my cow down to a show somewhere, and if the farmers down there have all got LoRa gateways on the Things Network, I can still track my cow, which is kind of nice. So you sign up for this. The whole aim of the thing is to build these communities. And you can buy devices from them as well. They'll sell you network gateways and endpoints, and they'll host your applications and pass your endpoint data into their back-end servers, because they're all very nice people, which is jolly good. In Hull, where I am, we have a bunch of gateways around the city. These are all the various gateway points. There's two in the middle there. We have a reasonable coverage. In the middle of Hull, I'm pretty well served, and in the outlying areas, not too bad. But you get over here, and things go a bit rocky. I want to see more gateways, particularly near where I live in Cottingham, which would be nice for me. But there's enough to make it useful, and there'll be even more coming down the tracks. The server is the back end. The TTN network works for free. What you do is you decide on a thing you want to do, track cows, for example. You build a cow tracking application. You then actually program your nodes with addresses that identify them on that application and turn them loose. And the Things Network does all the back-end stuff in terms of bringing in the messages from the nodes and making them available to applications on the end of the gateway. It's all broadcast, so anyone can listen, but each endpoint is key to a particular application, and the information between the two is encrypted using private keys. So you're not going to be able to eavesdrop and look at other people's messages and see what's in them. You can see the bytes go past, but they're encrypted, so you won't get much with them. And it's all based on AES-128, sort of a pretty good quality standard for security. So you can send messages in your application in a fairly secure way, and that's kind of important and rather nice. Now, when you have an application and you have some nodes that you want to connect to your endpoint, your bits and pieces, each node will have a unique address. You can't just attach a device out of nowhere. You have to get some keys from the Things Network application information, and there's two ways you can do this. You can burn the keys into the endpoint before it's deployed. That means that every endpoint must have different firmware in it, which might be a bit of a pain. Or you can put application root keys in the end nodes, and they will get their own individual keys when they attach to the network for the first time. So this is called over-the-air activation. That's how you do 10,000 devices. You don't have 10,000 devices, each of which contains a custom piece of software. You want to have 10,000 devices which get their keys from the network when they connect. So over-the-air authentication is the way to go. There's two ways you can do it. This one is great for prototyping and playing around and getting your first bits and pieces to work. This one's great for industrial strength, and that's kind of how you should view it. If I do personalization, I get these two keys, which I can take out of the device overview page on the Things Network, along with the device address and the application EUI, and I can actually hardwire those into my code. Here's the code from my little device I was playing with. This is inside the Arduino IDE, and I've got bunches of numbers. I've hidden some of the numbers because I'm scared you might all jump online and attack my devices, but there's basically a bunch of hex values that get pushed into the device to configure it. Great for small apps, but painful for lots of applications. If you do personalization, you can just put the key in and have the rest sorted out by the app. Now, this software that does this, you don't have to write it. It's all there. And these are my applications on the Things Network. I've got a few of them. Each of them has its own unique key. The ones that start 78B3 are Things Network applications. So all apps on the Things Network have those numbers. You can make your own application on your own servers. that's fine. You won't have those numbers in there in that case. The Things Network gateways look for application IDs with these numbers in there. If they see them, they go, ah, I'll pass that on. If they don't see that, they just go, oh, not for me, and they ignore it. That's how the kind of thing this works. So there's my endpoint. This particular case, my application has 2 endpoints, and you can see the number there is there, which is 2. An endpoint is linked to one application. My cow tracker will track my cows. If I have a pig tracker, then that will be a separate app, and the devices for that will be separate as well. Yeah, why not do that? Why not track your pigs as well? So I've got 2 devices here. One's called David Heltec 01 and Uno Node 01, and they have device addresses which are associated with them. And this is how I'll show you in a minute how it all works. Let's. This is all very well me showing you screenshots. This is very good. This is me getting information from my environment sensor. I can show you this in action. In fact, let's go back to my. This is the console for a device running in my bedroom at the moment. This device is taking temperature, humidity, air pressure, and a couple of particle density measurements for air pollution and pushing them into the cloud. And it's doing it every minute or so. Down here are the messages that were sent by the device when it woke up. These are activation messages saying I'm doing APB, activating my personalization. So it's saying, hello, I'm here, can I have a key please? The key then gets sent back into the device then goes okie dokie and starts sending readings, and here they are, all appearing as numbers in my program. How that happens we'll talk about in a second or two, but you can see I'm getting live data and it's updating every now and then, which proves the thing kind of works, which is nice. So that's my data, and each of these contains environmental stuff, which is what I'm sensing. If I look at the actual information along with my Celsius, humidity, pressure, and these 2 air quality index values, particle sensor ones, that's what I sent. This comes with it as well. This is when it was sent, the radio frequency used, the modulation, the data rate, the coding rate, and then for each of the gateways that picked up the packet, I'll get a little entry which says where the gateway is, and it'll give you some signal to noise ratio and spread values that you can use to work out how far away the other device was. That's kind of useful. I'm not using it at the moment, but airtime's interesting. 247 milliseconds. It took about a quarter of a second to send that. So not high data rate, but very low power, which is lovely. If you want to use the actual LoRa mechanism from any Arduino based device, the magic happens in a library called LMIC, which is actually an piece of free software you put into your program, and this will take your, it'll do the authentication stuff, it'll use the keys to get onto the network, it will take your packets of data and send them for you. In this application, the example code is this guy, lmic.setData, blah, blah, blah. This is a block of data starting at my data of this particular size, and bang, that just goes. So you can assemble whatever data you like as packets of bytes and send them using the Arduino IDE to build your programs, and it all just works. It's all rather nice. What I did with mine was, because I want to send 5 bytes that contain all this data, I've actually done some twiddling with the numbers to actually restrict the range and reduce the resolution to what I think is reasonable. So I'm actually making my 5 bytes of data by shifting and twiddling things around. You should really do that to reduce the amount of data you're sending. That's nice for other LoRa users. It makes less use of the spectrum, and it saves on battery power as well, transmitting smaller packets, which is good. At the far end, at the receiver, I can actually then have a little bit of code that reverses that. This runs inside the Things Network server. So I put this little piece of code together which says get the bytes, unpack them, take the values out, shift them and multiply them up to get the values back. The top 2, the particle density ones, are just 2 numbers that I send in individual bytes. And then I make this little tuple which is containing the answers, and that then I can use in my back-end process to do things with, of which more in a later session. Integrations are worth mentioning at this point, because this is how you take your information from the Things Network and push it into whatever you want to use. And there are a whole bunch of preset ones. There's data storage, there's HTTP, so you can actually just store data on the Things Network for up to 7 days and then go back and pull it back with a web request or whatever you want. Or you can make your device make a post to a web address with new data to get information. You could also use the Things Network with IFTT, if this then that, and Keying is very good for making dashboarding applications for showing pictures of needles and sensors and whatnot, which is kind of pretty. And you can use MQTT, of which more a little bit later as well. So this is all good stuff. I'm using data storage because that works quite well. You get 7 days worth of data storage, and I think a RESTful interface so you can use web requests to get your readings back. More of that in the next session. For now, I want to just round off talking about LoRa. One big limitation is to send messages to my cow, because I might wish to do that. I can't send them anytime I want because the LoRa network endpoint, the device on the cow, doesn't listen for incoming transmissions all the time. That would flatten the battery. What it does is it listens after it's said something. So after the cow is sent where it is, then the node will wait for a few seconds to see if anything comes back from the server. So your server should get the message, compose the reply, and send it back in that interval. That works well. And for cows, it means you could do things like configure how frequently the GPS sends the information up there, turn things on or off, change the dressing, I don't know, flash the cow light, whatever the cow light is, I have no idea. That's Class A, lowest battery life, least amount of data transferred. Class B, you can get your endpoints to listen at scheduled times, so it'll clock in, if you like, at irregular intervals. You can send things at that time. And Class C, which requires battery power, means it listens nearly all the time. Now, I've only ever bothered with Class A, and to be honest, the things I'm thinking of using LoRa for, I don't really want to send the node data particularly. In the case of my air quality sensors, of which more a little bit later, I'm just using LoRa to get information from my sensors up to my backend so I can draw graphs and do analysis on those data values. So for me, Class A is the way to travel. It works an absolute treat. This is actually how it would work if you did it. At the end of the LoRa message, an event is fired by the transmitter to say, I've sent it through, it worked okay. If you then have some data in your incoming message, you can then work through it. This particular bit of code in one of our sensors takes the message, assembles it, puts a 0 and then to terminate the string, and then it's a tiny piece of JSON we obey as a command inside the device to configure it. Now, this is a way I can send configuration information back to my sensors. I'm not particularly keen on it because the messages are quite long, say 15, 20, 30 bytes, which is quite long for a LoRa message in my opinion, but it's actually used, you can do it, it can be made to work. It's just not how I see LoRa, I personally see LoRa being used. There's no guarantee that when the gateway says something, the node will receive it. And in fact, the same is true the other way as well. A node can say, I've sent it, but it has no way of knowing it's got there until it receives a response from the server. It's a datagram. It's an SMS. You don't know whether it's been received or not. There's no delivery confirmation at all. That may restrict how things work, but the benefits, in my opinion, are so great that you can live with that. You can still make systems that work and are usable. I'm going to talk about MQTT a little bit later on, but what I will say at this point in the process is that MQTT, which is this way in which we link IoT devices together, works rather nicely with LoRa. The Things Network will provide MQTT brokers that you can connect to get messages into your MQTT network to move data around and receive things. So I'll cover that in a bit more detail a bit later on. It's just done in terms of the MQTT broker and device hang off a network connection to the Things Network server. That's how it works, but a lot more of that a little bit later. So LoRa on a page to finish off with, I guess. Cheap endpoint devices, they cost around a $5 for the actual LoRa transmitter. They'll run off batteries for a good long time. They're very good for small packets of data, not great for streaming video. You need gateways to link the endpoints together and servers to go behind there, but you can get all that from the Things Network. And if you're lucky and live in Hull, which means double lucky, then you will get use of the network gateways we're putting in for the Things Network. When you have an endpoint, it's linked to a particular gateway, particular application, I apologize, and it's part of that, but the application is managed by the Things Network and the gateways pass messages from particular endpoints into those applications. And so that's kind of how it fits together. Thank you for paying attention if you have been doing that, and more on this coming soon.